Okay, in today's lesson we'll be looking at ratio. Now we use ratio to compare parts of a whole. So if you look at this diagram here, you can see that there are 6 red marbles and there are also 3 yellow marbles. Now we say that the ratio of red to yellow marbles is 6 to 3. So 6 to 3 because 6 red, 3 yellow. This is written as 6, 3, and this here you'll know is called a colon from English, but we use it in maths to represent the ratio. Both numbers in the ratio 6 to 3 can be divided by 3. So we can simplify the ratio to 2 to 1. So because 3 goes into both numbers, we can divide both by 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. Okay, so our first example says what is the ratio of green to blue? Now to do this is quite nice. First of all, we count how many green there are. It says 1, 2, 3, 4. So it's 4. Don't forget our ratio sign. And then blue is 1, 2, 3, 4, 5. So the ratio of green to blue is 4 to 5. This can't be simplified, so that is our answer. On to the second one then. What is the ratio of red to yellow? So for red we have 1, 2, 3, 4, 5. So there's 5 red, a ratio symbol, and there are 2 yellow. And again, that cannot be simplified because only 1 goes into both of those numbers. So the next example says, or asks, what is the ratio of orange to yellow? And it also says to simplify your answer. So I'd imagine we have to simplify here. So let's start off as normal. Let's look at our orange. So we have 1, 2, 3, 4 orange. And how many yellows do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. So that's 4 to 8. Now, you will notice that we can simplify it, and it asks us to simplify it. So we can divide both of these by 4, because 4 goes into both. 4 divided by 4 is 1. 8 divided by 4 is 2. Now, you could have also, instead of dividing by 4, you could have also done this. So if you had 4 to 8, you could have divided by 2, which would give you 2 to 4. And then you could also divide by 2 again. So the answer is still going to be 1 to 2. So it doesn't matter if you find the biggest number that goes into them. So that here the biggest number was 4. You could also break it down into steps like we did here. You will get the same answer. So the next question, what is the ratio of red to green? And again, simplifying our answer. So let's start by counting the reds. 1, 2, 3, 4, 5, 6, 7, 8, 9 reds. And then for the greens, 1, 2, 3, 4, 5, and 6. So 9 to 6. Again, it's asking us to simplify, so we need to work out what goes into both. The number 3 goes into both, so we could divide them both by 3. 9 divided by 3 is 3. 6 divided by 3 is 2. And there is no other number other than 1 that goes into both of these numbers. So that is in its simplest form. And question 5 is slightly different. So it says a shade in the counters to represent the given ratio of black to white. So here we have our counters, and this is our ratio of 3 to 1. So what that means is that for every 3 black counters, they want 1 white counter. So 1, 2, 3 black counters, 1 white counter. So 1, 2, 3 black counters and 1 white counter. And for question 6, shade in the counters to represent the given ratio of black to white. And the ratio is 3 to 2. So that means for every 3 black counters, they want 2 white counters. So 1, 2, 3 black counters, 2 white. 1, 2, 3 black counters and 2 white counters. Now if you could make sure you've copied all of your examples, all of these examples and the notes into your big books, please. Thank you. So next we're going to look at simplifying ratios. Now remember, when we simplify, we look for a number that goes into every number, in this case every number in the ratio. We then divide everything by that number and we start again. And we keep doing this until the only number that goes into all the numbers is 1. So first example, simplify the following ratios. So the first ratio is 8 to 12. So we have to think of what number that goes into 8 that also goes into 12. Well, we can divide by 4, because 4 goes into both of them. And 8 divided by 4 is 2. And 12 divided by 4 is 3. Is there another number that goes into 2 and 3 other than 1? No, there's not. So our answer is 2 to 3. We could have also done it this way, and it'd still be right. So instead of dividing by 4, you could always divide it by 2. So that would be 4 to 6. And again, divided by 2 again. And that would be 2 to 3. So it doesn't matter if you can spot the quick method or if you've got to do more steps. It doesn't matter at all. You still get the same answer. So the second question is 18 to 24. So it's a little bit more challenging to spot, but a little tip for you. We know 18 and 24 are both even, so we can actually divide them by 2. Because they're both even, we know they divide by 2. So 18 divided by 2 is 9. 24 divided by 2 is 12. Now we look at 9 and 12. One number goes into 9 that also goes into 12. 3. So we can divide them by 3 as well. So 9 divided by 3 is 3. And 12 divided by 3 is 4. And there is no other number there. So our answer is 3 to 4. Now, much like the first question, you could have done this in one step. So for 18 to 24, we could have divided by 6 straight away to get an answer of 3 to 4. Number 3 is slightly more difficult because it's not obvious what goes into them. So we have 144 to 60. Now, like I just said, if you can't spot the big numbers that go into it, well, we know 144 and 60 are both even. So that means they could both be divided by 2. $144 divided by 2 is 72. 60 divided by 2 is 30. Again, it's not so obvious, so that's even and that's even. So we could divide them both by 2 again. And 72 divided by 2 is 36. 30 divided by 2 is 15. 2 doesn't go into both of those, but 3 does. So we could divide them both by 3. 36 divided by 3 is 12. 15 divided by 3 is 5. So you have 12 and 5. There is no other number that goes into both 12 and 5 other than 1. Question 4 then, that's a little bit more difficult again, because not only are they large numbers, but there's also 3 of them. There's 3 ratios. So we can still do the same method. Now, because, or you'll notice, they each end in 0. So that means we could divide them all by 10. So we have 21, 28 and 14. And that's a little bit easier to work with. The numbers are smaller. And one number goes into each of these, but 7 does. So we can divide them all by 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. And 14 divided by 7 is 2. And there's no other number that goes into 3, 4 and 2 except for 1. So this is in its simplest form as well. So our next example is it's £3 to 50 pence. Now what you'll notice why this one is different is that it has units. It's not just numbers, there's actually units there. And not just that, the units are different. So because we have pounds and pence, it's a good idea to change them to be the same thing. Now I think the best way, or the easiest way, is to always make everything into pence, so make it into the smaller unit. So there are 100 pence in a pound, so if I times the £3 by 100, so that's 300 pence to 50 pence. So now they're both in the same unit, we can simplify it like we have been doing. And again, both numbers end in 0, so that means they can be divided by 10. So 300 divided by 10 is 30, and 50 divided by 10 is 5. And one number goes into 30 that also goes into 5. But it's 5. So how many? 30 divided by 5 is 6. And 5 divided by 5 is 1. So ratio there is 6 to 1. So for every 6 pence, there's 1 pence. So the next question is 80 centimeters into 4 meters. Again, different units, we want to make them the same. And again, I would make them into the smaller units. I would change the meters into centimeters. There are 100 centimeters in a meter, so we need to times that by 100. So we'd have 80 centimeters to 400 centimeters. And now, because they're both in centimeters, we can actually now start simplifying. To do that, you'll notice both of them end in a 0, so that means we can divide both of them by 10. So 80 divided by 10 is 8. 400 divided by 10 is 40. And then 8 and 40, what goes into them? Well, actually 8 goes into both of those numbers. So we could divide them both by 8. And the answer is 1 centimeter. And 40 divided by 8 is 5. So it'll be 5 centimeters. Now make sure you've copied down all the notes and all the examples into your big books, please. Thank you very much.